Hi, this is number 2 video in the playlist where we've been looking at the 2017 higher paper for Edexcel. If you want to have a go at the paper, please do follow the link below in the description. You'll be able to download the paper and try each of the questions and compare your solutions. In the previous video, we stopped at question number 9, so we're going to carry on with question number 10. Now, question number 10, it says, show that this can be written in this particular form. Well, really, the way to do that is just to separate up what you've got to multiply. So what I would do is I'd write this as x plus 1, and that's going to be multiplied, and I usually use square brackets, x plus 2 times x plus 3. And what that tells me is that I do my work in the square brackets first. Okay, so let's just leave that x plus 1 on the outside. And then on the inside, what I'm going to get is x times x, which is x squared, plus 3x, plus 2x is plus 5x. And then 2 times 3 is plus 6. Now, if you're not sure about how I've actually done this calculation, then please do refer to some of the other playlists on the channel. Okay, so now I'm in a position where really I just need to multiply by this first part. So what I'm going to do is I'm just initially going to take the value of x first. I'm going to multiply that x by x squared. I'm going to get x cubed. And then x times 5x is plus 5x squared, and then x times 6 is plus 6x. Okay, hope that's all right for you. Then the second one is to take into account this plus 1, so I'm going to get plus, I'm going to write this as plus x squared rather than plus 1x squared, but hopefully that's okay with you. And then I've got 1 times plus 5x. And then I got 1 times 6, which is plus 6. Okay, and then really it's just a matter of tidying that up. So I'm going to gather up my like terms. I've got an x cubed term there, so I'm going to leave that as it is. And then I've got 5x squared and x squared, so that's going to be plus 6x squared. I've got a 6x and a 5x, so it's going to be plus 11x and then plus 6 at the end. And actually, that answers the question. If you wanted to, you could just make it easy for the examiner to write something like A equals 1, B equals 6, C equals 11, and D equals 6 if you wanted to. Okay, not a problem at all. Let's move on then to question number 11. In question number 11, we're looking at a graph. And it says the graph of the function of x, so it could be, it's a quadratic graph, so it could actually be x squared plus 5x plus 6, something like that. So it's a quadratic graph, we think, that's being drawn actually onto the paper there. And it says write down the coordinates of the turning point of the graph. Okay, well, the turning point of the graph is basically the bit at the very bottom. So it's actually where the graph starts turning back on itself, and it's this point here. Okay, so on there you'd be writing that x equals 1 and y equals minus 3. Okay, and then the next bit of it is it says write down an estimate for the roots of f of x. Well, that's basically the roots are where it crosses this x-axis. It's where the value, if you like, the value of y is 0. Okay, so I would look at that and I would probably say that there's 2 roots on there. The first one is minus 0.7, and then this one would be plus 2.7. You might be slightly different in your reading. They will give you a little bit of leeway on that, but I'd say minus 0.7 and then positive 2.7. Okay, and then the final part of this is it says use the graph. So use the graph to find an estimate for when the function is equal to 1.5. Well, that basically is the function of x. So all they're saying really is when x equals 1.5, what's the value of y? So if we take this ruler and I'm going to come down from x equals 1.5, and then I'm going to go across, and that would give me then if you like, an x value, beg your pardon, a y value of minus 2.8. Okay, hope that's all right for you. Let's move on then to question number 12. In question number 12, we're going to be dealing with indices. Very, very popular on GCSE non-calculator papers, so please do practice these because they do come up quite frequently. Okay, so find the value of 81 to the power of minus a half. Okay, so every time you see a minus sign at the top there, you need to make it just basically means the reciprocal, okay? So write it as 1 over 81 to the power of a half. Now, the power of a half basically means the square root. So what we're actually writing is 1 over the square root of 81. And the square root of 81 is 9. So therefore, the answer will be 1 over 9. Okay, hope that's all right for you. Let's move on then to 12b, and we've got 64 over 125 to the power of 2/3. Well, the easiest way of dealing with this is to kind of separate this 2/3 up. So what we would write is 64 over 125, and that's the power of 1/3, and then that whole thing is then squared. Okay, so let's just look at that for a minute, because what we mean by that is that this 2/3 is the same as saying 1/3 times 2. So therefore we can separate it up. And as we did before, a half means the square root, 1/3 means the cube root. So what we end up with is the cube root of 64, which is going to be 4, and the cube root of 125, which is going to be 5, and all of that is now going to be squared. So we've dealt with this bit. This bit here is the answer to this bit inside the square brackets. Okay, so to answer the question then, we've got 4 squared, which is going to be 16, and then we've got 5 squared, which is going to be 25. Okay, hope that's all right. Let's move on then to question number 13. I'm going to aim for this video to be about 30 minutes or so, and we'll see how far we get. Okay, so it says y is inversely proportional to the square of t. Okay, so what we mean mathematically by that, we would write that as y is inversely, it's a reciprocal 1 over, the square of t is x squared. Just be careful, it's not the square root, it's the square of t. Okay, so let's just have a look at that. It gives us some values, and it says, well, when x equals 1, y equals 9. Now, at the moment, I'm going to ignore these fractions. They're okay, but they're a little bit of a red herring, I think. So let's have a look at just a relatively straightforward one, where we're saying that 9 equals 1 over x squared, which is 1 squared. Okay, well, no, it doesn't. The only way that can work is if we put in what's called a constant here, which is this value here, and that's actually what we're going to work out. So if we want to work out the value of k, it's 9 times 1 squared, so that's 9 times 1, so therefore k equals 9. So when we're actually writing out the equation, and this is important, this is the proportionality, but we have to write out an equation, okay? So the equation is going to be y equals 9 divided by x squared. So that's actually the equation, okay? Alrighty, and then on to part B of that, and it says find the positive values of x when y equals 16. Well, all we do really is we take this equation, we just plug in the values. So if y equals 16, we're basically saying that 16 equals 9 over x squared. Okay, so if we want to work that out, you're going to need to do a little bit of manipulation on that one. But basically, if you multiply both sides by x squared and then divide through by 16, you end up with x squared equals 9 over 16. Now remember, this is the square of x, so therefore we need to get the square root. So the square root of 9 is going to be 3. And the square root of 16 is going to be 4. So in this particular case, x equals 3 over 4. Okay, hope that's all right for you. Let's move on then to question number 14. Now, question number 14 is a little bit tricky to kind of get a grip on what it is they're actually saying to you. And it says white shapes and black shapes are used in a game. Fine. Some of the shapes are circles Okay, some of the shapes are squares, that's fine. But let's just look at that for a moment. What they're saying is we've got white shapes and we've also got black shapes. Okay, so I think one of the ways of dealing with these sorts of questions is just take it a little bit at a time. Okay, so it says the ratio of the number of white shapes to the number of black shapes is 3:7. So let's just look at that for a moment. The ratio of the number of white shapes to black shapes is 3:7. So what that means is that 3 out of a group of 10 are going to be white shapes and 7 out of a group of 10 are going to be black shapes. Okay. Right, then it says the number of white circles, so we're only going to deal with this bit now. The number of white circles, number of white squares is 4 to 5. So let's just have a look at that next little bit. So I'm only going to deal now with the white shapes, and we've got 2 types of shapes. We've got white circles, and we've also got white squares. Okay, so in this particular case, the ratio of the number of white circles to white squares is 4 to 5. So what we're saying is that would be 4 out of 9 and 5 out of 9. Okay, and then we do exactly the same exercise with the black shapes. The ratio of black circles to black squares is 2 to 5. So I'm going to have, if you like, black circles. I'm sorry, I'm running out of room here. And then black squares. Okay, now in this particular case we've got a ratio of 2 to 5, so that means the black circles is 2 out of 5 and the black squares is 2 out of 7, I beg your pardon, and then 5 out of 7. Okay, hopefully you followed that all right, and then really it's just a case of working out the fraction of all the shapes that are circles. Okay, so we're interested in this, and we're also interested in this. So what I would do is I would say, well, actually, what I know is that 4/9 of 3/10 are white circles. So with this particular one, I'm going to have a look at white circles. And that's going to be 3/10 of 4/9. Okay. So if I work that out, or rather 4/9 of 3/10, so I've probably written that the wrong way around, but hopefully you'll get the idea. So that's going to give us then 12 out of 90. Okay, so let's do exactly the same exercise now with the black circles. With the black circles, I've got, if I put those down as black circles, so that's going to be 2/7 of 7/10. Okay, it's 2/7 of them are black circles out of the 7/10 which are black shapes. Okay, so if I then multiply that across, I get 14 out of 70. So if I want to work out then the fraction of all the shapes that are circles, what I've got to do is I've got to add these two together. Now, just looking at them, I've got 90 as a denominator and 70 as a denominator. That's too big, it's too difficult for me to do that. So what I'm going to do is I'm going to reduce this down. If I reduce it by dividing through by 3, I get 4/30. Well, that's a bit better. Or 2/15. So that kind of works out a little bit better for me. And then it's the same thing with this 14/70. I'm going to divide through by 7 and I'm going to get 2 out of 10. So basically those two fractions are the ones I need to add together in order to work out the fraction of all the shapes that are circles. So I'm going to look at 2/15 plus 2/10. Okay, well, when you add fractions together, you need to make sure the denominator is the same. So I'm going to change both of those denominators to 30. Okay, so I can say 15 times 2 is 30, so 2 times 2 is 4, and 10 times 3 is 30, 3 times 2 is 6. So I end up with 10/30, which will reduce down to 1/3. So the answer to the question is that 1/3 of all of the shapes are circles. Now I do absolutely understand that's quite a tricky question, so please do have a look at the printout. If you follow the link below, you'll go through to my website, you'll be able to print this off and have a look at it, or at least have a look at it on the screen if you've not been able to work through that particular question. Okay, let's have a look at question number 15. Now 15 deals with volume of a cone. Okay, and again, quite a popular one, but the key issue with this particular one, bearing in mind it's a non-calculator, is they're asking you for an estimate of the height of the cone. So really, they're very helpfully already giving you the formula. So what we're going to do is we're just going to basically plug the numbers into the formula volume equals 1/3 pi r squared h. Okay, so what I'm going to do is, rather than using 98, I'm going to say, because it's an estimate of the volume, I'm going to use 100. So 100 equals 1/3. Okay, now in this particular case, rather than using pi, I'm actually going to leave that as 3, I think. I'm going to put 3 as pi, okay? So that's easy enough for me, because 1/3 times 3 is going to be 1. So that works out very well. Okay. Bearing in mind this is an estimate, so they're not asking you to exactly calculate the whole question. It's just an estimate. Okay. So the value of r, well, that's 5.13. So I'm going to make that 5 squared. And then the value of h is what we're actually trying to work out, okay? So let's just look at that. What I end up with is 100 equals 1/3 times 3 is 1. That's fine, don't need to worry about that. And then I got 5 squared, which is 25h, okay? Or 25 times h. So therefore, if I want to work out h, I just divide through by 25 and I get 4. So in this particular calculation, I would suggest as an estimate, the height of the cone would be 4 centimetres. Okay, and then it says John uses a calculator to work out the height of the cones 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Give reasons. Okay, well, I actually rounded up. Okay, so I rounded up. And I will put, therefore, the actual height would be smaller. And if you just want to satisfy yourself, if you grab a calculator, you'll be able to work through that. And rather than using 5 for the radius, you can use 5.13, and rather than using 100, you use 98. Okay, hope that's all right for you. Let's move on then to question number 16. So in question number 16, n is an integer greater than 1. Prove algebraically that is always an even number. Okay, again, becoming more popular with these sorts of papers, so worthwhile getting to grips with these sorts of things. But the thing you've got to be careful of, I think, with this is going to be this negative sign in the middle here. It always makes life a little bit more difficult, but let's just sort of work it through and see how we end up. So I'm going to ignore the n squared minus 2 minus, but this n minus 2, I'm going to put n minus 2 times n minus 2. And as I usually do with these sorts of things, I'm going to put that into square brackets, okay? Because it reminds me then that I've just got to keep an eye on this negative sign. Okay, so we've got n squared minus 2 minus, and then I've got my brackets. N times n is n squared, minus 2n is minus 4n, and then minus 2 times minus 2 is plus 4. Again, if you're not sure about how I've done those calculations, please do have a look at other playlists on factorising and expansion. Okay, so now it comes into play where I've got to deal with this negative sign here, and I've got to remove these brackets. So I've got n squared minus 2, well, that's absolutely fine. And then I've got minus n squared, and minus times a minus is plus 4n, and then minus times a plus is minus 4, okay? So do be careful when you're working through these things. You need to be very careful with that negative sign. Okay, so let's have a look at that now. We could just gather up the like terms. But they made it slightly easier for us because this n squared and this minus n squared disappear. This 4n will remain. And then I've got minus 2 minus 4, well that's going to be minus 6, okay? So really when they're saying is that it's always an even number, what we're saying is that it's an even number because this can be factorised for 2. So we can write this as 2 times 2n minus 3, okay? And the reason that it's an even number is that it's always an even number as 2 is a fraction. Okay, hope that's all right. So we're 20 minutes into the video. We're going to work through to question number 17. That deals with probability trees, and we'll see how the time goes. Okay, so let's move on then to question number 17. It says there's 9 counters in a bag. 7 of the counts are green, 2 of the counts are blue. Ria takes at random 2 counters, work out the probability. Okay, so it's a very standard, actually, for question number 17, it's a very, very standard probability tree question. So what we would say is we've got red and red and blue counters. Okay, so in this particular case, I've got 7 out of 9 for, what have I got here? I've got green and blue, okay. So I've got 7 out of 9 for green, and then I've got 2 out of 9 for blue. And that's actually my first, what's called the first pick, okay? So this is the probability of Ria taking out a green counter would be 7 out of 9, or a blue counter would be 2 out of 9. So on the second pick, what happens is actually now there's only 8 counters left in the bag, okay? So this assumes that you've taken one of the counters away. So that's going to be out of 8, and that's going to be out of 8, and that's green, and that's blue. All right, so let's have a look at that then. So the first time round, if you took a green counter, then there are only 6 green counters left in the bag. Okay, so that probability would be 6 out of 8. Okay. With you taking a green counter the first time round, there are 6 out of 8 left, or there's 6 green counters left, but there's still 2 blue counters. So there's still 2 blue counters in there. Let's have a look then at taking a blue the first time round. Well, there were 2, there's now 1, but there's still 7 green counters left in the bag. Okay, so we're interested in the probability that Ria takes 1 counter of each colour. So the outcomes that we're interested in are green, blue, and blue, green. Okay, so we follow these branches along. You've got green, 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 blue, blue, green, or blue, blue. Okay, and again, please do have a look at one of the playlists on probability trees if you're not too sure about this. So to work out the probability of green, blue, it's going to be 7 over 9 times 2 over 8. So if I multiply that through, I get 14 over 9 times 8 is 72. Okay, blue-green is going to be 2 over 9 times 7 over 8. And that's going to be, again, 14 over 72, okay? So if I want to work out the probability of the 2 counters being different colours, I just simply add these 2 probabilities together. So I end up with the probability, or the total probability, is going to be 14 out of 72 plus 14 out of 72, which is 28 out of 72, and that's perfectly fine as an answer. You can leave it at that. However, if you're feeling particularly, you've got a bit of time on your hands and you want to cancel this down, go ahead and cancel that, and actually that will cancel through by dividing through by 4. You're going to get 7 over 18, whichever answer, that would be perfectly right. Okay, hope that's all right for you. We've just got a few minutes left of this particular video, so I think what we'll do do is we'll just carry on and we'll have a look at question number 18, which deals with a rhombus. Now, rhombus is pretty much the same as a square, but basically what's happened is it's just fallen over towards one side. So with a rhombus, what we're saying is all of these lines, all of these sides are equal to each other. And what it says is the coordinates of A are 5, 11. Okay, so that's 5, 11. And then it also says the equation of the diagonal DB is y equals a half x plus 6. So what we're saying is that if we have a line that goes from D to B, then this line has an equation of y equals a half x plus 6. Okay, and what they're asking us to do is to find the equation of the line AC. So it's actually this equation here. Okay, so the way I would do that is firstly to recognise that with it being a rhombus, this is actually a 90-degree perpendicular. So if we've got the line of the equation DB equals y equals a half x plus 6, then the equation of the line AC is going to be, in terms of the gradient, the negative reciprocal, okay, of this gradient. Now, there are a couple of different ways of doing this, but basically the way I do it is I say, well, actually, the reciprocal of a half is going to be 2, and it's the negative reciprocal, so it's minus 2x plus 6. Okay, now I've had conversations with students where they say, well, what you do is you multiply these two together and you get -1. That's perfectly fine, not a problem at all with that. I just remember it this way. Okay, so now I know the gradient of this line AC. All I would do then is plug in the value of 5 and 11 in order to find out the value of C. I'm so sorry, this is the value of C here. Okay, so I know the negative reciprocal, I know the gradient, but I've got to work out this value of C. Okay, so what I would do is I'd say at the equation, the point 5, 11, then we have 11, which is the value of y, equals -2 times 5 plus C. And if you work that through, you end up with 11 equals -10 plus C. So C must equal, bring this over, the value of 21. Okay, so if I put all of that together now, I've got my value of C and I've got my value of the gradient, so I can write out the line AC, or the equation of the line AC is going to be y equals -2x plus 21. Okay, and that would be the answer to that particular question. Okay, I hope that's been okay for you. We're going to leave it there. That's been a good 28 minutes or so into the video. Please do add a comment below if you're not sure about anything. I'll always come back to you. Have a look at some of the other playlists within the channel. Subscribe to the site, and I'll look forward to seeing you inside the next video.